Hey guys, before we proceed onwards and start using Firebase Firestore to save our messages and send messages over for storage, I wanted to quickly take a moment to do a swift deep dive on something that you might have seen in the last lesson that might still yet be a little bit confusing. So notice how in this line here, line 54, we created a cell by calling this method dequeue reusable cell with identifier. We provided the identifier that comes from that cell that we created in the custom zip, and we were hoping that our table view would just create this cell and slot it in. But right at the end here, we used this syntax as exclamation mark message cell. What exactly does this do, and what does it mean anyways? So in this swift deep dive, I want to talk about exactly this. I want to talk about typecasting, because that's pretty much what that as keyword does. Now, recently, I went to this workshop in Wales in the UK where we were casting sword from stone. So we were adding copper and tin into a crucible that was heated really hot, and then it was poured into this soapstone mold. And after the metal cools down, you end up creating a completely different shape, right? The shape of a bronze sword. Now, there was a lot more to creating a bronze sword, including 2 days of polishing the sword in Wales, which is freezing. But by the end, you create this beautifully shiny mirror-like surface of a sword, and it was really, really cool. So how does this relate to what we're trying to learn? Now, as you're coding and as you're looking at other people's code, you might notice these keywords as question mark, as exclamation mark, and is. And in this lesson, I want to explain to you what all of these keywords do and when we would use them. So here I've set up a playgrounds, which has something that you should already be familiar with from learning about classes and object-oriented programming in previous lessons. Here we've got 3 classes created, one called animal, one called human, and one called fish. The animals all have a name, and when you create any new animal, you initialize that new object with a name. Now, we've also created our human class to be a subclass of animal. It's inheriting from the animal class. So that means all humans also get to have a name. And similarly, our fish class is also inheriting from the animal class. So these are what you would call subclasses, and this is the superclass. Now, humans and fish can do all the things that animal can do, which is why it inherits, but it can also do some specialized things, like humans might be able to code, and fish might be able to breathe underwater. So there's really nothing new in this code here. And if any of this looks unfamiliar, then I recommend having a quick revision of the lessons that we did on classes and objects and object-oriented programming. So now that we've created our classes, let's go ahead and create some objects or instances from these classes. So let's say that I decide to create me, so Angela as a human, and we automatically get this initializer from the superclass animal class because human inherits from animal. And the name is going to be my name, of course. And then let's create another human. Let's create Jack, who's also a human, and his name is Jack Bauer. And then let's create somebody called Nemo. Nemo is a fish, and his name is Nemo. Great, so we've got 3 objects created from our classes, 2 humans and 1 fish. So let's say that we decided to create an array called neighbors. And these neighbors who live really close together are me, Jack, and Nemo. At this point, we've created an array using objects of different types, right? We've got Angela, who has a type of human, Jack, type of human, but Nemo has a type of fish. And they're allowed to fit into the same array because they have a common superclass, animal. So this neighbors array is an array of animal objects. That means if I was to pull out an item, say the item at index 0 from this neighbors array, you'll see that it still is an animal class. It doesn't revert back to the human class, even though we know that this is definitely of type human. Because the array has mixed types, in order to store them in this mixed array, they have to find some commonality, and that is of course the animal superclass. So now is where some of those typecasting keywords come in handy. Previously, we've seen typecasting in the sense that we've able to create a double. Let's say my double equals 0.0, and let's just do a quick Alt Option click check. You can see this is definitely a double data type. But if I wanted to create my double as an int, then I would use the int data type, open up a set of parentheses, and inside here I get to put in my double, and it's able to cast this my double, which has type double, into something that has type int. Now, this is not really quite typecasting, even though it does in fact change the type of my double into an int. This is actually achieved through initialization. So if we take a look at the documentation for the Swift Standard Library, you can see that under the document for int, it has a whole bunch of initializers. And one of these initializers is used for converting floating point values, such as doubles and floats. And this particular initializer is the one that's responsible for creating a new integer object from the double value, and it rounds towards 0. So without this initializer being created for int, then we wouldn't be able to do this and change the data type. But in our case, if we wanted this neighbor1 to be treated as the human that it is, we have to do something different. So first thing we can do is we can check what data type it is. So for example, we can say if neighbor0, which is this one, is of data type human, well then we can print first neighbor is a human. And if I go ahead and run this code, you'll see that what I get printed is in fact this, because neighbor0 is indeed a human. So we could perform this check, and it tells us what data type it is. And you can do this if you wanted to. Say you could check if Jack is human. And the thing is, we already know that Jack is human, and this is why when you try to write this code, which is extremely obvious already without any sort of checking, the Xcode compiler will actually tell you that this particular test is always going to be true, because there is no uncertainty about the data type of Jack. Whereas in this case, when we're tapping into the neighbors array, where everything is of type animal, and we said, let's say, try to get the item at index 2, so 0, 1, 2, and we said, well, what if neighbors at index 2 is human? And then in this case, we actually get nothing printed, because neighbors at index 2 is in fact of type fish. So this is keyword basically allows us to have a object from a certain data type and then check whether if that object is of that data type. So in this case, if we had a cell created from a UI table view cell and we check if it is indeed that data type between the left hand side of the is and the right hand side of the is. So this keyword is used for type checking. So let's say that I decided to go and create a function. Let's call it find Nemo. And this function takes a input in the form of an array of animal objects. So we're going to say find Nemo from as the external parameter name, and then inside the function we're going to refer to it as the animals. So now we've got our function created, and we're going to go ahead and loop through our animals array. So let's say for animal in animals. So in this case, we're looping through the array animals, and for every single animal in that array, we're going to run the code in here. We can either simply just print animal.name. So this is pretty bog standard sort of for loop kind of functionality that you've already learned about. And in this case, when the code runs, when I call find Nemo from our neighbors array, go ahead and hit run, then you can see that we've got all the names of our animals in our neighbors array being printed out. So that's just a simple for loop. But what if I actually wanted to find Nemo inside this array of animals? Well, I could say that if the animal that we're currently looping on is of type fish, then that seems pretty suspicious, right? Maybe that's going to be Nemo. So let's go ahead and print that animal's name property. So now what will happen if I run find Nemo from neighbors is that we're going to get Nemo printed out because it's looping through all of the animals and checking each of them to see if they match the data type of fish. And when it does, then it prints out the animal name. Now, notice how in this case, inside this set of curly braces, we're pretty certain that this particular animal that we've currently got access to is definitely a fish, right? Because we've checked if this animal is a fish before we actually trigger this block. But notice how in here, even though we're certain of that data type, we can't say something like, well, this animal dot breathe underwater, because that's what all fish data types can do, right? They have this functionality, breathe underwater. But in fact, it says value of type animal has no member, breathe underwater. So in this case, what's happening is that this particular animal, even though we know it is a fish, we've checked it, it still has that data type animal. So we're not able to tap into the specialized functionality of the fish. So what can we do in this case? Well, we can use something called forced downcasting, where we cast from the animal class down to one of its subclasses, like in this case, fish. So we could write something like let fish equal animal as exclamation mark fish. So what this now does is it takes that animal, which we've already checked and made sure is definitely of type fish, and we use the as exclamation mark to cast it down to one of the animal's subclasses, namely the fish class. So now with this fish created, we can now go ahead and tap into that method breathe underwater. And when we run our code, you can see that Nemo is breathing underwater. So the as exclamation mark is used when, let's say, we've created a cell, which is still the UI table view cell, which remember is the superclass, and then we wanted to turn it into a subclass. For example, our message cell that you saw in our code earlier on. Well, in this case, we can use the as exclamation mark, and now this message cell object has converted or cast its data type into a subclass. So going down, and this is called forced downcast. Now the problem with a forced downcast is that unless you're sure, say for example in this case, we're pretty sure that this particular animal that matches the fish data type can be cast down into a fish data type. But let's say that you decided to cast the neighbor at index 1, which is Jack, to a fish. So Jack's not going to like that very much, but let's go ahead and try it. Let's see what actually happens. So you'll notice that I'm not getting any warnings, any problems, any errors at all, because this is perfectly valid code. This is pretty much the same as if we did this, right? The compiler can't tell that it's going to fail. Now we know because we can see right now what is at index 1, but let me just show you what happens when I try to run this code. You can see that it's at runtime, when your app is actually running in the user's hands, when this line of code is going to crash. And it tells us that it could not cast value of type human to fish. So that's the problem. Now, very often what happens is when we're dealing with data that we're getting back from the internet or from APIs, they often have a JSON or some sort of array where we're not really quite sure what's actually in it, right? Otherwise, we wouldn't be fetching it. So in these cases, unless you're certain that this cast is going to work, then a better option is to add a question mark instead of an exclamation mark. But what this does is it turns this object that's cast from this object to a fish data type into an optional. So now if I check this data type, you can see it's a fish question mark. So that means if you wanted to be able to do something like fish.breathe underwater, then you will either have to use the optional chaining, like how it's inserted this question mark here, which says basically if fish is not nil, then call this method. Alternatively, you would have to use a optional bind, say if let the neighbor at index 1 can be cast as a fish, we'll then go ahead and run this code. Now, if I run this code again, you'll notice that it doesn't actually crash anymore because this is actually being skipped. And in fact, I can add an else statement to print that casting has failed. So let's run that code and you can see that it's the else case that gets triggered in this block of code. So the as keyword is a slightly safer way of performing this downcasting capability. Instead of simply just saying, cell is definitely going to be convertible to message cell in all cases, when you're not sure, it's better to actually use a as question mark. So this way, we only actually do the casting if it actually can be cast as the subclass. Whereas in this case, we can be pretty certain to downcast because we know that the animal is definitely a fish. Now, in other cases where you've written the code, say you've created the array, you know what each of the items are, then you can also make the case that a forced downcast in this case is probably okay. So the last keyword I want to show you is this thing called as. For example, in this case, we know that this fish object has data type fish, right? But what if we wanted to turn it back into the data type of its superclass? Well, we can say let animal fish equal fish as with no question mark or no exclamation mark, and then we can cast it to one of its superclasses. So in this case, we could say turn it into an animal. And this takes the object which has the class fish and raises up to the animal superclass. So now this animal fish has type animal, whereas it came from this object fish, which had the subclass fish data type. So the as keyword by itself is simply used to raise a object to its superclass's type. So it's another form of casting, but it's perhaps used a little bit less frequently. And the reason why it doesn't need to have an exclamation mark or a question mark is because when you take a subclass object and you convert it into a superclass, it's never going to fail. This is always going to work as long as this particular object that you're trying to cast is indeed inheriting from the data type that you're trying to cast it to. In other words, the as keyword is used to perform an upcast. That said, upcasting is performed a lot less frequently than downcasting, but it belongs in this set of as, so it's a good idea to talk about it. Now, the very last thing I want to talk to you about is some of these strange data types that you might have come across. This is a topic that's closely related to typecasting and working with types in general. Sometimes you don't want to be specific about the data type that you're working with. Sometimes you'll want flexibility, and you'll want your code to accept a range of different data types. And in Swift, we have something called any, which encompasses all objects, so objects derived from classes, from structs. Basically, it can be any data type, just like the name. Now, within that group of any data type, there is a subclass of any object data types. And these are objects that have to be derived from classes. So sometimes you'll see certain protocols that have a requirement where only an object created from a class can actually conform to that protocol. So they might use this data type any object in that way to limit things to work with classes. And then even more specialized are these NS objects, which are the objects that are created from the foundation classes. So remember how we often import foundation? Well, inside that foundation module, we get access to NS number, NS date, file manager, and a whole bunch of other objects that Apple has created. So if we were to head back to our code and where we've got this array of objects, right? If I was to create, say, just like an integer, right? Let's call it num and let's make it equal to 12. And I try to add this number to our array of neighbors, then you'll see that it's not really going to allow me to do that because there's absolutely no commonality between all of these guys. The only way that I can do this is actually by making my array of type any. So if I had an array of type any, then this is going to be fine. Any allows us to mix any type, literally. In this example, we're mixing the human type, the fish type, and an integer type, because Angela and Nemo are instances created from classes, whereas the integer is created from a structure. So this keyword any allows us to mix classes and structures or any other data type. So what happens when I change any to any object? Now we get an error. Why? Well, the reason is that any object restricts the types to those that come from classes. So in other words, structures are no longer allowed to play and they're no longer allowed to be part of our collection. And integers, strings, and doubles, these are all structures, which is why we get this error. And I can show this to you in another way. Let's say that our fish class was instead a structure, and structures of course don't have inheritance, so I have to delete all of this. But there we go, we've got our Nemo, which is created from fish, but right now if I try to run this, this also gives me an error. It says that Nemo, which has type fish, can't be converted to any object because any object requires that the object be created from a class, like the human class, where Angela and Jack are created from. But Nemo is created from the fish struct, which is not an any object. Now, let's say we change this to NS object, which means that we're even more limited as to what can go into our array. Neither Angela, Jack, or Nemo actually fit this criteria because we need to use one of the classes in Foundation that's created by Apple. So for example, let's say I decided to create a number that's created from the NS number class and I set it to equal to 12. Or let's say I create a word that's created from the NS string class and I set it to ABC. Well, these items can go in here, right? I could put num and I could put word. And if I take out Nemo, then you'll see that this is perfectly valid. These are both NS objects that can match this particular requirement. But as soon as I try to add in a struct, for example, our Nemo, or if I try to add in a human, which is created from our class, none of these will be allowed. So essentially, depending on how strict your criteria is, you can actually go through these very broad types, any object, and NS object, and it allows you to create collections of items that are more broad than just the classes that we've created ourselves. So now that you've learned all about typecasting, I have a small reading assignment for you. So if you have some time, I recommend heading over to this link, which you'll be able to find in the course resources, and just having a read of this page on typecasting to get a little bit more background information and learn a little bit more about this topic. So consider it an optional assignment. All right. In the next lesson, we're going to be using Firebase to save and retrieve data from the Firebase Cloud Firestore. And when we retrieve the data back, we'll have to use some form of casting in order to convert it into a data type that has the capabilities that we need.